Alright, question number 9. As shown in figure 4, a 1.34 kilogram ball is connected by means of two massless strings. Okay, so it is massless, so we can neglect that weight force lah. And then the strings are tied to the rod and are stretched. The tension in the upper string is 35 Newton. So I will put this as 35 Newton here lah. Then we have to sketch the free body diagram. Okay, now let's draw the free body diagram. So we have this here. And then we are gonna have weight force through the ball. And then we have tension. Okay. Sini. Okay, so this is the angle. Okay, so please remember, for circular motion, kamu perlu ada nilai angle and the radius lah. And then if you look at this question, we are actually missing an information lah, which is the angle and the apa tu nama dia, radius. Okay, sebab the radius is here lah. Tapi radius ni we can find using trigonometry lah. Okay. So that is your free body diagram, but then I think I'm gonna start with finding the angle dulu lah. Okay. So the angle can be find using sine theta lah. So sine theta is equal to opposite times over hypotenuse. So half of this is 0.85 meter, because sekarang ni kita akan buat satu triangle lah. Okay, supaya we can use trigonometry. Okay, so sine is opposite times dengan over the hypotenuse. So that is 0.85 over 1.7 lah. 1.7 meter. Bukan 35 Newton lah. Bukan itu. Kita akan guna meter sekarang ni. Meter dan meter. Okay, so this is gonna be equal to 30 degree. Right, after that we have to calculate for R dulu. Sebab usually we are gonna use R lah when it comes to circular motion. So R tu kita akan guna cos theta, which is equal to adjacent over hypotenuse. So R over hypotenuse, which is 1.7. So R is equal to 1.7 cos theta. Okay, so kalau kita perlu guna nilai, kita perlu find and then it's related to radius, kita akan guna yang ni lah. Then angle ni kita perlu lah memang. Alright, so now baru kita boleh cari the tension in the lower string. So the tension in the lower string can be directly found using y component lah. Kenapa bukan x component? Sebab sekarang ni x component we do not have the value of acceleration, centripetal acceleration. So bila kita guna y component directly, we can directly jumpa nilai T2. Sebab sekarang ni nilai mg can be calculated, T1 is given. Okay, so kita teruslah guna komponen y. So that is T1 sin theta minus T2 sin theta minus mg equal to 0. So rearrange untuk the lower tension, you will get T1 sin theta minus mg over sin theta. So dapatlah the tension in the lower string to be equal to 8.71 Newton. Okay. Next, we have to calculate the net force. Okay, remember, net force is the force yang ada acceleration saja. Kiranya force is equal to ma. Dia tidak equal to 0 lah. So, apakah nilai force tersebut adalah, it will be equal to the centripetal force. So, centripetal force is in the x component lah. So, that is gonna be net force will be T1 cos theta plus T2 cos theta. Okay, sekarang ni kan dia to the left. But why is it positive? Okay, it is positive sebab sekarang ni this tension here is pointing towards the center of the circle. Sekarang ni kalau kamu tengok di sini, the center of the circle is gonna be here. Okay, so bila the forces is pointing towards the center of the circle, dia ada direction similar to centripetal acceleration, dia akan jadi positif. Okay, so itu yang kamu perlu ingat, dia akan positif bila it points towards the center of the circle. Okay, so dari sini kamu sudah dapat kamu just perlu substitute. You will then get 37.9 Newton as the net force lah. Okay, next, this last question is the speed of the ball. So the speed of the ball ni kamu boleh sudah guna total force X is equal to MAC. Okay, so that is FC equal to MV square over R. So dari sini V is equal to FCR over M square root. Okay, so what is FC? It is 37.9 lah yang kita sudah kira di sini tadi. So kamu substitute, kamu akan dapat 6.45 meter per second lah jawapan dia. Alright, that is I think the part yang kamu akan rasa susah is mana? Macam tiada juga bayang susah ni. Tapi just make sure you are able to find, you still remember trigonometry lah. Kamu perlu ingat trigonometry supaya kamu masih ingat Soto Wacha ni. Kalau kamu faham lah Soto Wacha, it depends on which school. Because last time when I was a student, kami ingat dia by remembering Soto Wacha gitulah. Okay, and then the rest of this, it's just based on, I guess the confusing part is whether it's gonna be positive ataupun negative. But it is positive kalau dia towards the center of the circle. Itu je yang kamu perlu ingat. Ataupun dia follow direction of acceleration, centripetal acceleration. Okay, that is for question number 9.